This video is going to describe Chapter 3.4, direct variation. And we're going to use this formula, y equals kx. So keep in mind that x and y are simply points on the graph, and k is our constant, or our rate of change. Why we use the letter k is somewhat of a confusion, but it does actually stand for constant. So if you look at this graph, if we want to find what is the equation for the direct variation of this graph, we're simply going to use our formula for slope. So if you remember that, that's y2 minus y1 over x2 minus x1. And so I'm going to label these points. I can call this one x1, y1, and this x2, y2. And so I'm going to take y2 minus y1, so this is going to be 0 minus 4 over x2, which is 0 minus negative 1. First thing I probably want to do is fix that. So I'm going to slide this over to here, and this is going to become negative 4 over negative and negative becomes a positive, so this is over positive 1. So my slope is negative 4. Now this slope is also my k, or my constant, so as I'm writing an equation that's in the form of y equals k times x, I'm simply going to take this number and substitute it in for k. So my final answer would be y equals negative 4x. So the equation of this red line is y equals negative 4x. Now the second thing you would need to be able to do is take an equation and create a graph. So in that problem we got a graph and created an equation. Now we're going to take this equation and create a graph. So if you think about this equation, y equals negative 2x, this would be my k, which is also my slope. So if you think of slope as rise over run, and if it's negative 2, it means that really I'm going to be negative 2 over 1. So every time I run 1, I'm going to rise negative 2, keeping in mind that negative 2 means that I'm going to go down. So I'm going to start here at 0, 0, 0, the origin. I'm going to run 1, and then rise negative 2. It's going to put me here. Then from this point, I'm going to run 1, rise negative 2, which puts me here, and so my line is going to look something like that. All right, and then finally, this is more of what you guys might consider a story problem. Suppose that y varies directly as x, and y equals 72 when x equals 8. So I put this top paragraph on there just because I want you to start to get used to the wording. So the wording, suppose y varies directly as x, is how a lot of these problems are going to start, and then they will give you what y equals and what x equals, and what I need to do is figure out what is the constant. So if I know that I'm using the equation y equals k times x, I'm just going to substitute this in for y, and I'm going to substitute this in for x. So 72 equals k times 8. Right? In other words, this becomes, if I rewrite this using the commutative property, 72 equals 8k. I would divide 8 to both sides, and I end up with k equals 9. Which means that if k equals 9, I'm going to take this, put it into my equation, and so my direct variation equation is y equals 9x. Now, just keep in mind that that means that 9 is my slope for this line. So then when I come down to this second part, and usually there are two parts, the first one is to find what k equals, and the second one is now using that equation. So find x when y equals 63. Well, if I know that I'm using this equation, it's basically 63 is my y, and then I have 9x. So to solve this, what I would need to do is divide 7 to both sides. Sorry, divide 9 to both sides. One step ahead of myself. And then x is going to equal 7. Alright, so that's the types of problems we're doing with direct variation. Please make sure you finish the problems on the bottom of this page. Keep in mind that we will be having a homework check on Wednesday. Thank you very much for watching this video, and I'll see you in class.